Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the November 2022 IB Physics examinations. This is an SL paper 1 question and it's a multiple choice. Let's get started. A cell of negligible internal resistance is connected to 3 identical resistors. The current in the cell is 3 amperes. The resistors are now arranged in series. What is the current in the new cell? Now, to solve such a problem, it's a two-step process. Okay, so first let's identify what is the voltage drop or potential difference across this first resistor, this complex circuit. Well, we can use the Ohm's law, which is V is equal to IR. This is in your data booklet. Using this Ohm's law, we can solve our problem. Well, we know that each resistor has a resistance R, so R ohms, and R ohms. So we need to find what is the effective resistance of this circuit. Now we know that 1 over R effective is how it works for parallel combination. So let's find out what is the effective resistance in this parallel combination. So you get 1 over R plus 1 over R. When you add these two together, you get 2 over R. Okay, now you take the inverse of this, so you get that the R effective is equal to R over 2. Okay, R over 2, and that's for this part alone. R over 2 is simply for the parallel part of this circuit. So I'll delete all this and bring this closer. Right? R over 2 is for the parallel. Now we know that the total resistance, R total, will be the resistance of this parallel, so which is R over 2 plus just R is the summation of the resistances, which I get finally is 3R over 2. 3R over 2 is the total resistance in this circuit. Now, but that's not what I want to find out, right? I want to find out something that stays the same between both combinations and which I can use to solve the problem. So we know the resistance and we know the current, 3 amperes. Can we not solve for the voltage of the cell? Why the voltage of the cell? Because the cell itself does not change over any of the combinations. So we know that the potential drop of the cell should remain the same. We can use that to solve our problem. So if I say V is equal to I, which is 3 amperes, times the total resistance of the circuit, 3R over 2, I know that the potential difference is equal to 9R over 2. Okay. Now, what else can I do? Now I can redraw the circuit because I know that all 3 resistors are going to be connected in a series. So it's going to look something like this. All the resistors are now in a series, something like that, with the current moving this way. Now I know that again each resistor has a resistance of R, and I know that the voltage potential difference of this cell is going to be 9R over 2. Why? Because the cell itself never changed. The combination changed but not the cell. Hence the potential difference by the cell should remain the same as well. 9R over 2, that's what I calculated earlier. Now using V is equal to IR, I can now calculate the current. Right? I can calculate the current. I can say 9R over 2 is equal to I, which what I want to find out, times the total resistance of this new circuit, which is R plus R plus R, because it's all in series, it's simply just the sum. So that is 3R. Now cancel out the R's, cancel out 3. So I is equal to 3 over 2 amperes or 0.5 amperes. And that's your answer. Not 0.5, sorry, 1.5. My mistake. 1.5 amperes. Thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.